The example using dictionaries we will look at is determining the frequency of each word in a text file. For example, in a book, the word "the" is probably one of the most frequently used words. Here is a slight variation of the example in the textbook. I've hard-coded the file name so I don't need to enter it when I run the program. We'll use Shakespeare's play Hamlet since it is in the public domain. I've also used the newer version of the string formatting to output the results. We start by reading the entire file in as one string. We convert it to lowercase. Remember, strings are immutable, so the lower method returns a new string. Next, we'll iterate over the common non-alphabetic characters, including punctuation, and change each one to a space. Because the string data type is immutable, this is creating a new potentially long string each time through the loop, so it is a relatively expensive operation. Next, we'll split the string into words. Since we replaced the non-alphabetic characters, the list should contain lowercase words with no punctuation or other special characters. Since we will have a large number of words, and dictionaries are efficient, we will use a dictionary to store each word with its frequency. The words will be the keys and will map to the frequency of that word. As we iterate over each word, if the word is already in the dictionary, we get the current frequency for that word and add 1 to it. This is the correct thing to do as we just process the word one more time. If the word is not already a key in the dictionary, it means this is the first time we have come across the word in the text, so we put it in the dictionary with a frequency of 1. We could do this with an if statement that checks if the word is in the dictionary, and if so, replaces the value for that word with one more than the current frequency. If the word is not in the dictionary, we insert it with a value of 1. This can be done without an if statement using the get method. The get method will return the frequency of the word if the word is already a key in the dictionary. We can add 1 to it and update the value for that key. If the word is not in the dictionary, we told the get method to default to 0, so we add 1 and we'll insert the word into the dictionary with a frequency of 1. We'll now ask the user how many of the most frequent words they want to see. We'll use the dictionary's items method to get a list of tuples. Each tuple will contain the words and its frequency, but the tuples will be in a random order. We want to see the most frequent words, so we need to sort by the second item in the tuple in descending order. We'll first sort the list of tuples, which will sort them by word. The sort method sorts tuples by checking the first item in the tuple, and uses the second item in the tuple to break the tie if the first item is the same. In this case, all the words will be distinct, since they were keys in a dictionary, and a key can only appear once in a dictionary. Now we'll sort them by the second item in the tuple. This may make it seem like there was no point in sorting by words first, but there is a reason we did that. Python's sort method is a stable sort, meaning that the relative order of two entries that have the same value will not change when we sort. This means if two words have the same frequency, after the second sort, those two words will be in the same relative order to each other as they were before the second sort. Thus, the words with the same frequency will be in alphabetical order after the second sort. For example, if we had this list of tuples which is sorted by word, and now sort them in descending order by the second item in the tuple, this will be the result. The word "and" stays before the word "the," since "and" was before the word "the" before the call to sort, and they both have the same value 3 that we are sorting by in the second sort call. We also see some new options for the sort method here. We can call it and specify the values for the parameters key and reverse, which have default values. We tell it to use our byFrequency function to access the value for a given item in the list. Since each item in the list is a tuple of two values, our function says to use the second item of the tuple, which is at index 1 in the tuple. We are also telling the sort method to sort them in reverse order, so the sorted list will have the highest frequencies at the beginning of the list. Finally, we print out the most frequent words and their frequencies. We unpack the tuple into its word and frequency, and print out the word left justified in 15 spaces, and the frequency count right justified in 5 spaces. We'll run it and print out the 55 most frequent words. We can see that "the" was the most frequent word. Near the bottom we see a three-way tie with a frequency of 95, and note these 3 words are in alphabetical order. The second version shows that the Python standard library has an option for using the specific element of a tuple when sorting. Instead of writing our own function to access index 1 of the tuple, we can import the itemGetter function from the operator module. When we call the sort function, we can pass the result of calling the itemGetter function with a parameter 1, and that will use the first index of the tuple to sort the elements. This version will produce the same output as the previous version. In this third version, we'll use the time module to determine how long it takes to count the frequencies of each word. The time module has a time function that returns the number of seconds since January 1st, 1970. We can get the time before the code we want to measure, and then again after that code completes. The difference between the two times is the number of seconds it took to execute that code. The other option I am showing you is that we can use the item getter function to first sort by the item at index 1 in the tuple, and break ties by using the value at index 0 of the tuple. This would work better if we wanted to sort both in the same direction. Our previous version sorted the frequencies in descending order, and the words in ascending order. This version will sort them both in descending order since we use the reverse option for the sort method. We'll run it and enter 55, and see that the words with a frequency count of 95 are now sorted in reverse alphabetical order. We can also scroll up and see how long it took to process the words in the for loop to get their frequency. Hamlet has over 30,000 words, and you can see that it takes a fraction of a second on my computer, so the dictionary is very fast. In the fourth version, we'll show you how we could do this with a list. If we didn't have a dictionary, we could store a list of lists, where each sublist is the word and the frequency of the word. As we process each word, we must search through the list and see if the first word in the sublist is the word we are processing. If so, we can add 1 to the second item in the list to count the frequency. Once we find a word, we don't need to continue checking the list. Before we start the loop that searches for a word, we set found to false. If we find the word, we set it to be true. When the loop ends, we can check the value of found, and if we didn't find the word, we append it to the list with the frequency of 1. Because the dictionary can use a formula to determine word keys in the dictionary, in most cases it does much less work than searching through the list. Since we already have a list of lists, we can use the sort method as we did before. We'll run this and see it takes 1 to 2 seconds on my computer compared to a fraction of a second with a dictionary. This should convince you that looking up a key in a dictionary is much faster than searching through a list to find a value. In more advanced computer science courses, you will learn techniques to analyze the efficiency of algorithms without writing and timing them.